Hello everyone. Hope you all are doing good. As you know already, we all are stuck up in our home only because of coronavirus, which is badly spreading everywhere. So, as per our board and principal sir order, have to take a revision classes through the internet media. So, hence today I am going to take a revision classes on elements of machine design and theory of machine subject for 4th sem students. In this subject, I am going to explain unit 6, that is CAMS. In these slides, I am going to cover the introduction part of the CAM and some definitions of the CAMS, follower and classification of the follower, classification of the CAM and some terms used for the CAM, and also the displacement, velocity and acceleration diagrams when the follower moves with simple harmonic motion mechanism. First of all, we're going to understand what is meant by cam. So here cam is a rotating machine element. It is one type of rotating element which is used in machineries, which gives reciprocating or oscillating motion to another element, that is called as a cam. So whatever we are getting the reciprocating or oscillating motion to another element, that element is known as follower. So these are the two definitions, important definitions in the cam chapter, means that cam and follower definitions. So the cam and the follower have a line contact and constitute a higher pair. The cam are usually rotated at uniform speed by a shaft, but the follower motion is predetermined and will be according to the shape of the cam only that is to be moved. The cam and the follower is one of the simplest, one of the most important mechanism found in the modern machineries. The cams are widely used in inlet and exhaust valves for the internal combustion engines, in automatic attachments of the machines, paper cutting machines, spinning and weaving textile machineries, feed mechanisms for the automatic purpose only. Next, classification of the cams. Actually, cams are classified in many ways, but following are the two types for example for syllabus point of view. So first one is radial or disc cam, that is shown in the figure A. The follower reciprocates or oscillates in a direction perpendicular to the cam axis. The cam is shown in figure A. Second one is cylindrical cam, is shown in figure B. In cylindrical cam, the follower reciprocates or oscillates in a direction parallel to the cam axis. So the follower rides in a grooves at its cylindrical surface only. So hence it is called as cylindrical cam. So cylindrical grooved cam with a reciprocating or oscillating follower is shown in figure B. These are the two types of the classification, that is cams. Then next, classification of the follower. So follower may be classified as into the four groups. First one is according to the surface in contact. It is further divided into four types. First one is knife edged follower. It is shown in the figure A. When the contacting end of the follower has a sharp knife edge, it is called as knife-edged follower. The next second, roller follower, when the contacting end of the follower is a roller, it is called as roller follower. It is shown in figure B. Third, spherical faced follower, when the contacting end of the follower is of spherical shape, it is called as spherical faced follower, is shown in figure C. Another one, flat faced follower, when the contacting end of the follower is perfectly flat faced, it is called as flat faced follower. It is shown in figure C. One thing we have to remember, that is the follower end, which and how the contacting will be taking place, according to that one only that follower defines. Then second group is according to the motion of the follower. It is also divided into two types. First one is reciprocating follower. When the follower reciprocates in the guides as the cam rotates uniformity, it is known as reciprocating or translating follower, is shown in figure A and D, means that it is somewhat similar to the A and B to this according to the motion of the follower group. B, oscillating follower, when the uniform rotary motion of the cam is converted into the predetermined oscillatory motion of the follower, it is called as oscillating follower, is shown in figure E. Then third classification, according to the path of the motion of the follower, it is divided into two types, radial follower and offset follower. Radial follower means when the motion of the follower is also an axis passing through the center of the cam, is known as radial follower. It is shown in figure A and E. Both are in radial directions, so hence all are radial followers. Then second, offset follower, when the motion of the follower is along an axis away from the axis of the cam center, it is called as offset follower. The follower is shown in figure F. So these are the some classification of the follower. It is very much important for exam point of view. You just go through the previous question papers. Most of the question will comes from this topic only. Please go through this classification of the follower. Next, moving on to the next point, that is terms used in the radial cams. Some of the terms are used while drawing the cam profile, which are very much important. Those are just like base circle, prime circle, pitch curve, pitch point, pitch circle, addendum, dedendum, like that. So many terms we are using, but for important purpose we are going to discuss some parts only. Firstly, base circle. It is the smallest circle that can be drawn to the cam profile. Second, trace point. It is the reference point on the follower and is used to generate the pitch curve. In the case of knife-edged follower, the knife-edged represents the trace point and pitch curve, is shown in the cam profile. Third one is pressure angle. It is the angle between the direction of the follower when the motion on the and normal to the pitch curve. This angle is very important in designing the cam profile. If the pressure angle is too large, reciprocating follower will jam in the bearings. Next, pitch point. It is a point on pitch curve having the maximum pressure angle. Pitch circle. It is the circle drawn from the center of the cam through the pitch point. Next, important, prime circle. It is the smallest circle that can be drawn from the center of the cam and tangent to the pitch curve. Then lift or stroke. It is the maximum travel of the follower from the lowest position to the topmost position. That is called as lift or stroke length. So these are the some terms which are very much important. In some time in the exam they may ask some definitions like prime circle, lift or stroke, like that. Okay, you have to be aware of these things. Next, displacement, velocity and acceleration diagram when the follower moves with simple harmonic motion mechanism. So this is the displacement diagram with extended line shows the velocity and acceleration diagrams. So this is clearly understand. So whenever we are going to solve the problems regarding the cams, initially while solving the problems, displacement diagram is first we are going to draw. After drawing the displacement, extended lines are to be drawn which shows velocity and accelerations of the cam profile. So whenever the follower moves with simple harmonic motion, their force velocity diagram consists of sine curves and acceleration diagrams is a cosine curves is clearly shown in above figure. The velocity of the follower is 0 at the beginning and end of its stroke and increases gradually to a maximum at a mid stroke. On the other hand, the acceleration of the follower is maximum at the beginning and at the ends of the stroke and diminishes to 0 at mid stroke. So this is very much important. He may ask for 7 to 8 marks on this one. So you have to practice this diagram carefully. At the same time, another one comes displacement, velocity and acceleration diagram when the follower moves with uniform acceleration and retardation. Similar to this one, only acceleration and velocity diagrams will differ. So you please go through the notes whatever I am given in the classes. So this is all about some important part of the cam chapter. In the next video I am going to discuss how to solve the problems of cam with analytical method and graphical method. Okay, thank you. Keep studying.